Good morning, guys. I'm going to make a video presentation about bunkering and discharge of water ballast. So let's start, guys. This is a Panamax vessel, a 7 hole, and he's presently at anchorage. So let's just read this scenario. MV Max Panama with a present displacement of 29,650, which is about 5.32 meters, has a center of gravity of negative 10.17. Forward of midship and her LBP is 215. You plan to load or discharge the ship as follows: to load and discharge at the same time, meaning you are loading bunkering and to discharge ballast. Okay. When you say center of gravity or LCG, this is what it meant of center of gravity. Okay. This is your amidship. Since your present LCG is negative 10.17, so from forward, you measured about 10.117 going forward, because from amidship measured any point forward is negative, and from amidship measured backward at any point is positive. Since you are negative, so it is somewhere around here. So this will be your vertical line of your present LCG of negative 10.17. So that is what it meant. Okay. Now let's analyze this displacement of 29,650. 29,650. So this is your displacement. So 29,000 should be between 520 and 540. So 29,000 is in between. 29,690. Okay. So what is his drop? Corresponding drop is 532. So meaning he is in ballast condition or ballast condition. So he's not loaded. Okay. And her LBP is 215. How did you get your LBP? LBP is this one. LPP or LBP is 215. Okay. So go back to the scenario. And this is now the bunkers that is going to load in FOT 1 center 250 and FA2 number 2 port is 400 and DOT number 2 is 44 metric tons. So they are at bunkering, which is in this situation. So they are going to load bunkers to the vessel. So this is a more small vessel, and they're going to load bunkers, okay, to the vessel. That is what it meant. Now, sorry. And the four-peak tank, another tank is to discharge cargo. So how do you discharge four-peak or after-peak? Four-peak is can be by gravity or by ballast pump, and after-peak usually discharged by ballast tank. Ballast by the ballast by the motor or ballast by the using the engine, the motor, ballast motor to take out ballast in your after peak. This is an example of gravity by ballast. So from after peak, you just open the valve and all the water will go out from the vessel. Okay, then the same manner, the same manner, open this one. Replenish water on ship images. Okay, enter. Replenish H. For images. They have a picture of that. I hope we have. Replenish, say. How do we get this? Replenish water. Just put this loading water. Thing. Fresh water. Loading fresh water. Take me time. How do you do that? We don't have replenishing. But anyway, it is the same as this. This could be a small boat with fresh water and replenish water to the vessel. In this case, this is bunker, but you can also use a boat with fresh water to load fresh water to the vessel or replenish water to the vessel. It's the same procedure. Okay, I hope that you have the idea. Then let's go to the problem or the equation or the scenario. So you're now also loading fresh water from drinking water, freshwater tank, and freshwater tank port side to load freshwater and to discharge the ballast of after peak and to load uh, diesel oil and fuel oil. So these are the amount that are going to load and this is the amount that you're going to discharge and this one also to load freshwater. These are the LCGs for each tank. Okay, so you have the LCGs for each tank. Okay, now you apply this amount to your trim stability sheet. Okay, we have a trim stability sheet. This is how it looks. You have your compartment. This is the weight. Okay, put this the weight. And the LCG and the LCG moment. So since we don't load any cargo, put it to 0. And this is now your FO. This is the amount and the corresponding LCG. So what you do with this weight, you multiply with your LCG, that will be your LCG moment. Okay, like your initial displacement is 29,650. Okay, take note your initial is 29,650 and your drop is 5.32 meters. So with initial displacement of the weight of displacement of 29,650 multiplied with your LCG, that will be your LCG moment. So that is how it works. Okay. Since we don't have any cargo, you put 0. Okay. Then you have your fuel oil. FOT number 1, center, number 2, FOT, port side. These are the amounts. So 520 multiplied with your LCG of negative 35.29. This will be your LCG moment of negative 18351. So with 400 multiply with the LCG, and this will also be the amount. Now we also load in DOT number 2 port side of 44 multiply with your LCG. This will be your LCG moment. Okay, then go down. We also load, this one is loading. Okay, and you also to load fresh water. Your drinking water is 36 tons. Your freshwater tank port side is 36. Multiply with the LCG. Okay. Multiply with your LCG. That will be your LCG moment. Then your after peak, you're going to discharge after peak and for peak tank. This is which I showed you. This one. So you're going to discharge your ballast water from after peak and for peak. So that's why it's negative. So your weight times your LCG, this will be your LCG moment. So with your after peak multiply with your LCG, this will be your LCG moment. Now, ballast being discharged is negative 482. Constant is 0 and light ship is 0. Why? Because you have your initial displacement, your constant and your light ship is already included in this present displacement, which is this one. With your initial displacement, your constant and your light ship is already included in this amount, this figure. So you don't need to put any amount on your constant and your light ship because it's already included in this present displacement. I hope that's clear. Okay. So with these figures, all these weights, and deduct it with the discharge of ballast tanks, ballast water, your new total displacement will be 30,224. Okay, and your new LCG moment is this one, that 303,359, which is negative. Now to get your final LCG, the formula is LCG moment, which is this one, divided by the new displacement of this one. Then your final LCG is negative 10.04. Forward your ship. Okay. I just make this one. Okay. That will be forward your ship. Okay. To give an idea, okay, your present LCG is negative 10.15. Okay, from amidship forward, that will be 10. After loading these bunkers, fresh water, and discharge of 100 tons, 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 100 discharge of ballast water, your new your final LCG is now negative 10.04. That will be in this situation. So from your present LCG, because of the weights loaded and the ballast discharge, this will be your new final LCG. This one. That will be about how much? That will be 10.04. Okay, 10.04. So that will be what you call the GG1, from G shifted to GG1 of about 0.13 meters. Okay, negative because you are still forward of your image chip. Okay, that's why there's a sign just to notice that you are still forward of the image chip. So from here, the initial G shifted to this one position. That will be your GG1 because you have already loaded and discharged some ballast. That's why the G center of gravity is shifted to this point. I hope that's clear. Then once you have your new LCG and this in your displacement, what will be his drop? So take note, okay? This is your new displacement and this is your new drop. Take note that take note that the displacement before bunkering or before discharge of ballast is 29,650 metric tons. But when you already loaded the ballast, loaded the fuel oil, fresh water, and discharge of ballast, your new displacement now is 30,201 because you have loaded ballast, fresh water, and discharge of ballast. Loaded, I mean, FO. This will be your new drop or your departure drop or new drop. So from this drop, you take all the values of LCB, LCF, MTC, TPC, and this is already taken out of your new final LCG. Okay? So from this displacement, we go to the hydrostatic table. 30, I go to the hydrostatic table. Okay, that is how much is your new displacement. New displacement is, I think this one. We will, yeah, this one. What is your new displacement? Is 30,204. 30,04. Put here 30,04. 30. How much? 30,204. 30,204. That is 5 meters and 42. So let's say 30,04. To give you have an idea, is 30,04. So it is somewhere 30,04. So it is around here. Okay, 30,04. Something here. So that will be 30,42. Okay, 30,42. I 542. So it is somewhere here. Okay, 30,42. And what is now the corresponding figure of LCB, LCF, MTC? We'll try to find out here. This one. That will be, if we round up this one, that will be 5.42. Your TPC is 5909, 5900, 5900. Your LCB is negative 1015, negative 1015. Okay, round it up. LCF is negative 903, negative 903. Okay, MTC is 76459, 76459, 76459. Okay, so that's all that you have to extract from the hydrostatic table. Okay, you have now your final LCG and your LPP is 215. The next thing you have to do is solve for your trim or the side trim. So the formula is displacement times final LCG minus LCB over MTC times 100. So your displacement was, what is your displacement? Is 30204. So this one. What is your final LCG? Is negative 1004. 1004. Minus your LCB. LCB is negative 1015. So you minus first this one, LCG minus LCB, which is your longitudinal distance is 10. Okay? Which is this one. It will be, this one is 10. Okay? And your displacement will be displacement times 0.10. Your metric tons, MTC is 76459 times 100. That will be 76459 times 100. Okay, and your displacement times your distance, which is this one. Then multiply this one, that will be 3061. Multiply MTC with 100, that will 76459, and your trim will be 0.04. Okay, I will show you how is that. Put this equals, click this one, then times 0.01, that will be 361. Put here equals, click this one, multiply with 100, click 100, and that will be this value. How to get the trim? Put equals, click this one, you divide it with this one, and then you will have 0.04. Okay, that will be trim by the stern because it's positive. Take note, when forward of midship is negative and up of midship is positive. Since it is positive, that's why you are trimmed by the stern by positive. Now, guys, another point to, okay, I'll just show you. This is your LCG is negative, final LCG is negative 10.04, and your LCB is negative 10.15. Okay, I will show you how it is explained here. Okay, take note that you have more value of your LCB is more value of your LCG, meaning your LCB is from this point going to this one. This is the vertical point of your LCB because it's more value than your LCG, which is negative 10.15. So meaning LCG is behind, no? Behind of LCB. So when he is behind, the rule is if LCG, this one, is above or behind LCB, it is trimmed by the stern. So that is the reason why the trim is positive. Okay. The another explanation take note of this by analyzing this value. Take note that LCB is ahead of LCB, okay, by looking at this one. And he is behind of LCB. Since he is behind of LCB, you will know right away that he is trimmed by the stern because he is a little bit less than LCB. So what it means that he is already trimmed by the stern. So as the saying goes, if LCG is above, which is behind of LCB, then you are trimmed by the stern. I hope that's clear. No? When you say final LCG, the total weight of the vessel, the total weight of the cargo, all weights that is in the vessel, the gravity pull is to put it downward, like this arrow. So you have to, the weight of the entire vessel plus the cargo or all weights on the vessel will push this vessel downward. While the buoyancy, which is a science, it is the force pushing the vessel upward. That's why you have a buoyancy, meaning this one pushes upward. So the vessel upper part will go up and this will go down. That's why you're trimmed by the stern. Okay. If your LCG is behind of LCB. But it is in forward, so that purpose of the weight, all the weights will go down and the buoyancy of the vessel pushes up. So you will be trimmed by the head if LCG is on the forward part. But here it is above. So this goes down, this goes up, you are trimmed by the stern. So that is very clear. I hope so. Now, we have already our trim here. Then we go down. The next thing we have to do is to find the change of drop forward. Change of drop forward. The formula is 1/2 LPP plus LCF over LPP plus trim, times trim. So transpose, your 1/2 LPP is 107.5 because your LPP is 215. 1/2 of 215 is 105.5. Okay? So 105.5 plus LCF. What is your LCF? Is negative 903, which is LCF negative 903. Okay? I hope that's clear. Over your LPP. So add this one. 901 negative 903 plus your 107.5, that will be 98.47, which is this one, over your LPP of 215 times your trim of 014, which is this one. Okay, so divide first this one. So what you do, equals divide by 215, that will be 0.058, multiply with your trim. So what you do, equals, click this one, then times your trim, and that will be 0, change of wrap will be 0 to 0. So next, you find for the change of drop up. So that will be trim minus your change of drop forward of this one. Then your change of drop up will be 0.02. Okay? Excuse me. Then you apply now the equation to get your forward and aft drop. Okay? Forward and aft drop. since your mid drop or your final drop is with just displacement, your final drop will be 5.42. So you put here forward 5.42, up 5.42. Apply your forward and up correction. Your forward correction is 0.02 and up correction is 0.02. You minus your change of drop forward because you are trimmed by the stern. So this will be a light drop. So you negative, you minus this one, that will be 5.0. Then you add this change of drop up, that will be 5.44. So 5.44 minus your up drop of 5.44 minus your forward drop, that will be 0.04, which is exactly the same as what you have computed with your design trim, okay, or change of trim. And your main drop will be 5.42, which is also the same with your departure drop or final drop. Now, there's another solution here. Hydrostatic drop or your main drop is 12 point. Okay, put this one here. Okay, so your main drop minus your change of drop forward of 0.02, that will be forward drop of 5.0, which is the same. You add your trim of 0.04, then your final drop up will be 5.44. Okay, so this is one way of, this is manual computation of finding the new displacement and the departure drop plus your LCG, final LCG. Okay, so from here, this is your manual computation. Okay, manual computation. Now we will apply this one now to the program. So we go back, go to the program, and I will go to form number 6. Okay, how to find trim when handling several moderate weights. Take note that our initial drop is 5.32, which is with present displacement of 29650 of the drop of 5.32. From here, we don't know what is his trim, so we presume that this is even keel. So from here, you put your forward drop of 5.32, then your up drop of 5.32. Okay, then your actual midport is 5.32 also, 5.32, and your actual drop mid starboard is 5.32. Okay, now now the density at birth is 1.025 and final drop will also 1.025 or after. Now let's not first take note of this. Just proceed to this program. Okay. 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 What I mean is, take note that our final drop. So you have this is now your main drop, right? Now take note that your final drop is 5.42, right? 5.42. So what you do, Actually, guys, this one is if you are trimming, you're to compute for trimming two hoods. That's why this is the formula. Is this program is designed for the drop of trimming two hoods. Forget the final drop. Trimming two hoods. Okay. So since 42, you put it here. 42, 5.42. Then you will not get your sinkage. Like for example, I put here 6 meters. Take note of the sinkage. Then he will have a sinkage of 0.68. Then he will have compute the recommended cargo total for trimming. So go back that our final drop is 5.42 or departure drop is 5.42. 5.42. Then it will take 10 centimeters to vessel to sink to reach 5.42, meaning from mid drop of 5.32, you have to sink of 10 centimeters so that you will reach the final drop of 5.42. Okay. Now, this sinkage, we will convert this into metric tons, which is this one. So how do we get that? The formula is K8, K, and 8, that will be your sinkage, times M3. M3 is M and 3. This is your TPC. With this your final mid drop, guys, you have to interpolate the TPC. So once you get this final mid drop, you interpolate the TPC of 5.42 and that will be 5.01. So again, to get the recommended cargo to load, you click this one, then you will have K8, which is your sinkage, times your TPC, which is M3, times 100, then you will have a value of 590. That is recommended cargo to load for trimming. So you scroll down, then you put here the arrow, put here 590, 590. Once you put 590, this is the actual to load cargo to load for trimming. So what will be the results after you load 590? Take note that your mid drop is exactly the same of 5.42 and your sinkage is exactly the same of 10 centimeters or 0.1 meter. Okay? Then what he says, then you go to trim holes 2. So you go to trim holes 2. Take note of the remaining cargo to load. This is the program is trimming with 2 holes. Okay? So remaining cargo to load is 590. This is your initial drop. Excuse me, this is a trim, mid drop, no trim, and empty CLCF support. Okay. Let's say that you're trimming all this 1 and 7. Put 1 and 7. Okay. I'm sorry. 7. This could be delete. Or you can put 2 or 6. Okay. Depending which one would you like for trimming. But in this case, I put 1 and 7. Okay. And what will be your desired trim? Take note, in manual computation, our trim is 0.0 meters, or the desired trim as computed was, where is that desired trim? The desired trim was 0.04, so we put 0.04 4 centimeters. Okay. Now You have already your desired trim. What will be our going to load in number 1, which is 270, and up will be 314. 270, you put here 270, and number 7 will be 320. Okay, you have the 320. 320 if you run it up, and your final drop is 540 forward, up drop is 544, and min drop is 542. Take note, drop forward by manual computation, your forward drop is 540, up drop is 544, your min drop is 542, and your trim is 0.04, which is exactly the same. Forward is 540, up drop is 5.44, your trim is 0.04, your min drop is 5.42, and your deflection is 0. So where did I get this mid drop? So you just click this one, you go to form 6 and click this one. Okay, then he goes there. Your main drop is this one, so put equals, click this one, then you have this value. Now this is trim holes 2. We go to the original program, the trimming holes. Okay, trimming holes, how to find trim when handling several weights, which is form number 6. So in form number 6, you scroll down and take note that number 1, you have to load 270. This is the LCG, and number 7 is 320, and this is the LCG, and the count. Final drop here, forward will be forward with 5.40, 5.44, trim is 0.04, and your min drop is 5.42, then you have a 0 deflection. Take note of this drop, exactly the same with this one. Okay, now we go to the next program, which is the trim by table. Trim by table, trimming table. Okay, take note of the cargo to load, which is 590, and our trimming hole is 1 and 7. This is the weight that we're going to load in number 1 and number 7. Now we have to check now the forward correction of hold number 1, forward and up correction of hold number 1, and 7, forward and up correction of hold number 7. So we go to the trimming table. This is the name of the vessel, and we go to hold number 1. See, take note, guys, take note that your min drop is 4.42, and this one up drop is 5.44. It is almost to 6 meters. Instead of using the 5 meters, I use the 6 meters. So in number 1, forward is 6.3. Put there, forward 6.3, and up is negative 3.8. Up is negative 3.8. So we go to hold number 7. Hold number 7, forward is negative 2.8. Okay, forward is negative 2.8, and up is 6.9. Up is 6.9. Okay. So once you already put all the corrections, then this will be his final drop. Final drop forward is 5.40, which is the same, and up drop is 5.44, which is the same here, and your min is 5.42, min is 5.42, and your min is 5.42, so your trim is 0.04. 0.04. Trim is 0.04. Okay? And your deflection here is 0. It's the same. Okay? This is your initial drop, mid drop, and your 0 trim here. This is now your final drop. Now here, I'm going to show you in node number 7, you're going to load 320 here, and forward drop correction is negative 28, 6.9 here, 6.9. And after you load number 7, you will load number 1 of 270, and your correction is 6.3, same, and up is 3.38. Now, why do we have to load first in number 7? Because you will have a good trim. So when you have loaded 320 metric tons, this will be your initial drop. After loading number 7, you will load in number 1, then will be your final drop. And your deflection is 0. Okay? So where did I get this one? You can click this one. Okay. Go to hold number 6. Go to your final departure mid. And your mid drop is this one. Click this one. There you go. Then the last one is how to find drop when handling weights involving large changes in min drop. So assume that the loading density is 1.025, and upon completion will be density is 1.025. Okay? This is your initial drop. Okay? That is your initial drop. This is initial drop of 5.32. Up is 5.32. Okay? Then put all the weights that you have bunkering of FOT center, all the bunkers you put here with the corresponding LCG. Then you discharge your ballast up for peak and after peak, which is negative 250, negative 20, which is this one, guys. Okay? This all these figures you put there in your program. Okay? Then you put your press water, that is positive. Then your final LCG is negative 10.392. Take note of this final LCG, and your program, your final LCG manual is negative 0.4. Okay, that's manual, and the program is negative 10.039 or 0.4. Okay, and his displacement is 30175. 30175. What you got here is 30204, but you have still get the same of the final LCG. Okay, and the drop here is mid drop is 5.14. Manual is 5.42. Okay, and the final drop of this program forward is 5.39. What we got here is 5.40. Updraft is 5.44. Updraft is 5.44. And your trim, your min drop is 5.42. Min drop is 5.42. Okay. And your trim is 0.04. Trim is 0.04. Okay. And deflection is 0 here. Deflection here is 0. Okay. Now, you have how much this program for number 6. Trim 2 holes, same drop. You have trim table. Okay, the trim table. You have the same drop. And your final program is this one. That's form 7. Then you almost have the same drop here. Plus your manual computation. Okay, of your final drop, this one. Okay, so this is 1, this is 2, trim table 4, this is 1, 2, 3, 4. Okay, this is trim 2 holes. And the last one for number 6, this one, you have the same drop. Okay, so you have approximately 5 programs to back you up with your computation. Lastly, guys, I want to emphasize this one. This table, okay, this table, take note, do not use or touch this table. This one is exclusively used for form 6, which is form 6, to extract the value of LCF, meaning this one, guys. LCF in question, number 6, change of drop forward, which is one, number 6, this one, guys. Number 6, okay. In number 6, change of drop forward, take note of this LCF. So number 6, change of drop forward, the LCF here. The LCF here, do not use this one. From the initial drop, do not use this LCF. What you use is from your departure drop of 5.42, you use this negative 903. So where did you get this 5.42? This is your departure drop or final drop of 5.42, which is this one. And which is 5.42, this is the interpolation for your LCF. So your LCF in for number 6 of number 6, which is change of drop forward, how to find the change of drop forward, which is number 6 here. Change of drop forward, the LCF here is not this one, do not use this one, but instead this one. Okay, I hope that's clear. And number 2, this formula can also be found in form 7A in exercise number 12. CD is equal to change of drop is equal to 0.19 or 0.2, which is formula form A1. This is for A1 and number 12. For A1, this is number 12. So change of drop forward, guys, take note again of this LCF. Okay. What you're going to use LCF here is this one, 9 negative 03. Okay. That is what it meant here. Number 3, do not use LCF value of 9.08, which is this one. Do not use this one. Found in the initial drop of 532. So the initial drop is 532. Do not use the value of negative 908, which is the LCF. And here instead, use the LCF value of 903, which is this one, found in the departure drop of 5.42. Okay, so I hope that's clear, so that you will not get lost. And that's it, guys. If you like this video, please click the like button, share, and subscribe. And please don't forget to click the notification bell. Thank you for watching and have a good day.